ESI's role in research is to connect the MIT faculty in ways that they wouldn't necessarily be connected so that they can actually have the greatest impact in the world. ESI hosts a seed grant program, and it's an open call of research topics to the entire MIT faculty. And often that work is difficult to fund because it's multidisciplinary and it is leading edge.
We work with using industrial byproducts, so that could be waste products from really any kind of industrial activity. We focus on making use of those in value-added ways. So the origin of this project was actually with some support from India. We focused in on a set of pulp and paper mills that were generating a bio-based ash, so meaning burning agricultural residues to generate energy to run their facilities, but as a result had a pretty significant waste byproduct. And we were able to develop a process that was low cost to make a brick that could be a replacement for fired clay brick in the region. This research effort began 4 years ago, but with the support from ESI in the past year, we've been able to extend what we were looking at to other waste materials, other applications, other regions of the world. And that has real implications on my research because it lets me investigate these problems at those multiple scales with the right tools, with the right sets of research questions, and with the right partners.
I do not only teaching, but also research in the field of chemical metallurgy. Chemical metallurgy is about the reaction of metals with the environment. Specifically in my group, we are looking at the use of different forms of energy than are traditionally used. And could it help in reducing environmental impact? We find that this is actually very possible. We could make directly iron and oxygen. So no more CO2, but instead oxygen, which is a pretty valuable element. Major global mining companies are now coming to say, can we build something together? So that's something we are pursuing with the help of the ESI. Metals have a huge environmental impact, and the question is really how can we continue to use steel in a manner that impacts less the environment while enable mankind to continue to benefit.
Our group focuses on the way that microbes transform chemicals in the environment, in the ocean. That transformation process is the creation of gases like nitrogen, dinitrogen gas, and also nitrous oxide, which is a potent greenhouse gas. Our group uses a combination of field studies where we get onto research boats and we go out on cruises, we collect samples and we bring those back. Then graduate students, postdocs, and other researchers in our group set the task on measuring different aspects of that in order to make progress on understanding these fundamental processes that are happening in the ocean. I wouldn't be able to do the work I'm doing without the ESI seed grant. It's been absolutely instrumental.
My work focuses on converting methane emissions to carbon dioxide equivalent emissions. And this is really important for evaluating technologies like natural gas. And historically, each gram of methane emitted is counted as 25 grams of carbon dioxide equivalent emissions. Now that conversion factor was originally meant as a placeholder, but then it ended up getting used in all sorts of policy decisions. What you can see is an unintended consequence of applying that number, meaning that you'll have more global warming than you thought you were going to have when applying that number. ESI has been hugely important and helpful in this work. It can be difficult to find funding to support these kind of big ideas where it's not necessarily clear at the outset, and developing that new understanding or that new theory often has the most practical impact.